Welcome guys, welcome back again. Now today we are going to discuss one of the major protocol of the network layer, we can say, and that protocol named as ICMP protocol. And ICMP stands for Internet Control Message Protocol. So here the name itself suggests the Internet Control Message. So here the messages are going to be controlled. So in order to control the messages, we required one protocol, and that protocol is what the ICMP protocol. So let's start with the background guys. So here if you try to understand, let's say we have discussed about the IP protocol, that is Internet Protocol, and the nature of Internet Protocol is connectionless. And here, no one can rely on that particular Internet Protocol because it is connectionless. There is no guarantee of any packet to reach from source to destination. Okay, so this is what the first statement in the IP protocol. Still, we are believing that IP protocol because it's provide us the fast nature as part speed we can say. And here, but if you go with the more drawbacks of this IP protocols, here the IP protocols are lagging about not drawback but the laggings about few terms, and that few laggings are what it IP lacks of error control. So there is no any error reporting and correction mechanism. Let's say if I have a R1, let's say it is what the source, and let's say it is what the receiver, and in between let's say there is a network. What happen if sender is sending the message to receiver? Let's say if there is no any positive acknowledgement from receiver to sender that I have received the message. Okay, so source cannot confirm, or source cannot rely that whatever the message I have sent is received by receiver or not. So there is no any reporting message available. There is no any feedback mechanism available in this particular IP protocol. So here, let's say in someone here R1 router, any packet discarded due to some reasons, that information is not going to be known in terms of IP protocol to the sender. So error reporting and correction mechanism is not available in IP protocol. And second, an IP protocol is again a lack of assistance and the query mechanisms. So there is no kind of what we can say any mechanism, support mechanism provided to the datagram, so that datagram or the person who is sending the message is going to be rely on that particular scenario. So in order to provide such a uh, mechanism, we require to learn something new. And because what happen if something goes wrong? Let's say in between any router, in between any router in this network, any router, if something goes wrong, what happened? So here there is a one protocol, and that protocol name is what the ICMP. It is a network layer protocol, and there are two main purpose of this network layer protocol. Very first protocol, because everyone, let's say, in order to maintain the security and safety of network and maintaining a successful communication between devices is essential. So if let's say sender and receiver is there, in between the sender and receiver, we require to maintain a security, safety, and a successful communication to be happen, because our ultimate aim is towards send the packets and send the datagram source to destination, so that that is only what the purpose. And second, being a supportive protocol in the in the internet protocol suite, ICMP is often preferred by the network device to send error message and similar functionality. So this is second function, that ICMP protocol is going to be send the messages, that is error messages, and some other functionalities. What it conveys? It conveys the what happened wrong, okay, and where it happened wrong, to whom happened wrong. So that message is going to be conveyed by the ICMP protocol. So what is going to be ICMP provide? So ICMP provide error control mechanism and assistance to the datacom. So it is what we can say, if any source sending in message to the receiver, and that message is going to be assisted by ICMP protocol, that this is what the root, this happened something wrong. Okay, so everything is going to be supported by ICMP. And again, if any error occurs, and that error to be reported to the source, so that source can take a decision that it has happened something wrong, and that we have to work on that. Okay, this is what these purposes and the services are provided by the ICMP. Let's check how it is going to be provided. And here we can say there is a position of the ICMP where it is a network layer protocol. So like IGMP, IP, ARP, RARP, ICMP is also a network layer protocol. So these are the main purpose, right? I hope you are getting the motivation of this ICMP protocol. Now, in order to provide the error control and the messages, we have ICMP messages, guys. There are two types of messages. Very first category is a error reporting message, and second will be what the query messages. So query message will be for the assistance, and this is what the error control. This is what the two purpose. Purpose number one is what the error controlling, and purpose number two is what the assistance. For here in a error reporting message, there are 5 different subcategories are available. That subcategory we are going to discuss, like a destination unreachable, source screen, time exceed, parameter problem, redirection. There have a type also. And in the query message, what we have two sub points we can have: echo request and reply and timestamp request and reply. Okay, so this message we are going to discuss in detail later on. Now, there are two basic nodes are available or slogans we can say. Uh, and let's say the packet discarding is done at the router level, and router can be discard any packet due to, let's say, maybe reason can be router buffer is full. Let's say there is a congestion, there is a packet is mismatched. The reason can be anything. Okay, so how it is going to be discard? And let's say if router have the many of packets, let's say router comprise of ICMP packet, IGMP packet, UDP packet, TCP packet, IP packet, whatever the packets are. Okay, now here the priority of packet discarding is start from, let's say, if I have any router, let's say if any R1 router has these 5 packets, so definitely very first the ICMP packet will be discarded, then very less chance to discard the IGMP packet, then will be very less chance to discard the UDMP packet, and the lastly the TCP packets are going to be discarded, but mostly TCP packet never can be discarded. So this is what the sequence, this is what the priority in this direction the packets can to be discarded. So this is what the fact about the ICMP, guys. Okay, so let's start with the messages. Very first is what a general format of the message, so that error reporting can be fit in this particular format. So here the fields are type indicate. The type indicate what type of error it is. Here we are going to fill it that type. Then code indicate, is there any subfield available of that type? Let's say if I am saying that there is a destination unreachable, so why which reason the destination is unreachable, that need to be put up over here. Then checksum. Checksum is what for computing the checksum, the checksum field should be 0. Okay. Then rest of the header. The rest of the header is a specifier for each message type. So for this message type, it is going to be fill up. Then data. Data section in error message carries information for the finding the original packet that had the error. What was the error was there, that data is going to be found there. In query messages specifically, data sections carried extra information based on the type of query. So here additional information is going to be maintained over in this particular data section. So this is what the general format. With the help of the general format, we have to use that particular query messages and the error messages. So let's start with the messages are over here. Okay, now there are some interesting fact about this. Uh, let's say first we start with the category 1 message, and the category 1 is what the error reporting message. One of the main responsibility of ICMP is what to error the reports. So as we are discussing now the error reporting messages, this is what the main responsibility of ICMP protocol is, what the error reporting of errors. Then ICMP always report errors to the original source who has sent the data, who has sent the datagrams to that particular, the ICMP is going to indicate and inform that something goes wrong. But there are some facts about ICMP protocols, right? ICMP error messages. These facts are very important. Okay, very first fact: no ICMP error message will be generated in response to the datagram carries an ICMP error message. Let's say if this ICMP is originally designed for what? If IP datagrams, let's say, discarded, if IP datagram, let's say, lost, then ICMP message will be generated. If IP datagram lost, then ICMP message will be generated. But if ICMP itself discarded or itself lost, there is no any ICMP message going to be generated. No, this is what number fact one, fact number one. Then fact number two: ICMP error message no ICMP error message will be generated for the fragmented datagram. That is not the first fragment, means for the first it is generated. Let's say if I have a fragment, this is what the IP packet, let's say 1, 2, 3, 4, 5. These are the fragments are available. For if this is discarded, no ICMP generated. If this is discarded, no ICMP. This is generated, no ICMP will be generated. And this is also no ICMP packet error message will be generated. But for the first IP datagram or first IP packet, if for this ICMP packet is going to be generated. So this is what the purpose of this second chapter. Then third is no ICMP error message will be generated for the datagram having multicast addresses. Like in multicast addresses OSPF class D, there will be no facility to generate the ICMP error message. And the last one, no ICMP error message will be generated for the datagram having special address such as 127.0.0, that is what loopback address, and or let's say second will be what 0.0.0. That is what the default address. So these are the facts about, guys. So here we can say ICMP is helping others to report, helping everybody, but no, there is no any helping mechanism to ICMP itself. If something goes wrong with the ICMP itself, so there is no any mechanism. So this is what the purpose of the slides. Okay. Now let's start with the very first message of the error reporting, that is destination is unreachable. So destination unreachable type is 3. So we have put a type is 3. And the reasons to destination unreachable can be start from 0 to 15. These are the 16 reasons available. Why this destination is unreachable. So here we have a list of destination unreachable. Let's say if this is the 0, the network is unreachable. That we due to hardware failure. If it is 1, the host is unreachable due to hardware failure. Then 2, protocol unreachable. Third is port unreachable. These are the reasons, guys. Okay. For example, if we go with the type number 9 and 10, so it is what the communication with the destination network prohibited by admin. So admin have the policy, they have configured that particular protocols, and they have restricted to somebody's to don't allow them. So these are the reasons, guys. Okay. Then 10 is what destination host prohibited by the admin. Okay. Then 11, network unreachable for service due to some services. So these are the reasons, guys. Okay. So in order to say destination is unreachable, there can be multiple reasons. Let's say if I'm saying, let's say, source to receiver, if somebody is not reaching, let's say if I have example, if somebody is listening the wanted to listen the online class, but at the end in online class, there can be reason that the data pack is not available at the receiver end, the network is not possible at the receiver end, he is not interested to listen that particular lecture. Let's say any cable has broken down, let's say data pack is not available, let's say coverage is not available. So these are the reasons. This can be the reasons available over here. So this is what the first error reporting message, and type 3, that is what the destination unreachable. Second will be second error reporting message is what the source quench format. As we know, guys, there is no any flow control and congestion control mechanism in IP protocol. What do you mean by flow control? Let's say there is a source and there is a receiver. If the source speed is high and receiver speed is low, or let's say vice versa, receiver is high speed and source is low speed, so there will be no any synchronization occur. So rate, what we can say, the rate at which both are producing is not going to be synchronized to each other. So here they are supposed to be maintain the flow of each the entity, that is source and destination. Okay, that mechanism is missing in the IP protocol. So here in this message, and this source quench message inform the source that datagram has been discarded due to congestion in router or destination host. So here, due to congestion in router or destination, and congestion can be occur due to, let's say, buffer, can be traffic, can be anything. Okay, and that congestion can occur due to some reasons. And this source quench message, and it tells to source that it should slow down the sending, because let's say if something is happening wrong, and let's say there are plenty of messages are available, but that receiver is not listening, receiver is not possible to listen to all the messages. So it is better to inform to the source that, can you please slow down your speed, can you please slow down your rate of the data transferring, so that I can one by one I can easily read that messages. So this is what the source quench message, that source have some kind of, let's say, quench for particular time, that he is not able to listen that messages properly. Okay, because the rate, because the congestion can may vary. Okay, so here the type is 4 of the source quench message, and there is no any subcode available for this one, and rest of the fields are as it is for other purpose. Okay, then there is a third sub messages of the error control, and that is what a time exit message. And time exit message, there will be two cases. Whenever router decrement the datagram with the time to live value is 0, it discard the datagram and send the time exit message to the source. Okay, so here the source is going to be informed if the time exit due to time to live field. Generally, time in decrement at each hop. If error occurs, then datagrams create a loop and wander around the net. So that, let's say, we know, guys, there is a TTL field available to every datagram, and it indicate that that is what the that datagram is going to be sent from reach to the sender to receiver. If at every hop it is going to be decremented by 1, and it is going to be, let's say, become 0, that time it needs to be informed that the datagram has not received, but the TTL field has been become 0. So it is better to increase that TTL field so that the receiver can receive. Okay, so this is what the case number 1. And second will be when the final destination does not receive all the packet, not received all the packet in set time, this is fixed time, it discard the received fragmentation and send the time exit message to source. Let's say if in any particular time t0, if the receiver is not receiving all the messages, all the fragments of the source, let's say that time it is going to be informed by the router at the source that this is time up, and what we can say, we have you have to send the message or you have to resend the message again and again. This can be done at the time exit message. So here is a time bound. Within the time bound, that all the things is going to be done. So here the type is what 11, and the subcode will be 0 and 1. 0 for this one and second for this one. Okay, so this will be the case of the time exit message, and it inform that the activity is supposed to be carried out within a specific stipulated time, so that everything going to be smoothly on the network. So this is what the time exit message. And there is another message, and that message is what the parameter problem message. So it's a parameter problem message itself, the parameter problem, that field problem, not datagram problem. Okay, his type is 12, and subcode, there are two subcodes are available. Very first is the ambiguity for 0, and the missing is what one pointer not in use. So these are the two subcodes are available. What happened in the subcodes? Code 0, there is an error or ambiguity in one of the header field, that is what the whatever header format is available, there is ambiguity available itself. There is no any correction in the IP datagram, IP header itself. In this case, the value in the pointer field points to a byte with the problem. So this is what the first case. Then for example, if the value is 0, then the first byte is not a valid field. If the value is 0, there is no valid field. Okay, so this is going to be available regarding with the any field. Then code number 1, the required part of an option is missing. In this case, pointer is not used. So these are the two cases. How it is happened, let's say the parameter problem error message generally means that something is wrong with the IP datagram itself, and that the datagram is being discarded. So here is the error of, let's say, datagram field itself, IP datagram field itself. IP datagram itself. Okay, then ICMP parameter problem messages are used to indicate that the host or router could not interpret an invalid parameter in the IP origin 4 datagram header. So this is related with the IP datagram header. Okay, and if you go with the code 0, there is an error or ambiguity in one of the header file. In this case, the value of pointer field point to the byte with the problem. For example, if the value is 0, then the first byte is not valid. So here, let's say if this is the frame format available, let's say IP datagram, we have IP header, datagram and data, header and data. If something goes wrong in, let's say something, some address is put it wrongly, some destination put it wrongly, some type field to put it wrongly, some version full put up wrongly, and that kind of messages are going to be shown to that particular source, guys. So this is what the parameter problem. Then there is another message, and that message is what the redirection message. Okay, if something goes wrong on the route, so the message is to be redirected. So the type of this redirection will be 5, and there are 4 different subcodes, that for 0 to 3. And what are these one? So here ICMP redirection messages are used by the router to notify the host on the data link layer that better route is available for the particular destination. Let's say there are plenty of routes available, and if something go, let's say if some route has broken, it means what the error has occurred. But here that in order to notify that the alternative routes are available, so can you please follow that routes? Okay, so for that purpose there are codes. So code 0, redirection for the network specific route. A network specific route can be redirected. So let's say if I am the 0 1.0, I can have a 2.0 network specific route. Then host specific route, let's say if I want to reach to the 1.1, so I can reach via something else. Okay, code 2, redirection of network specific route based on the type of service, which type of service is going to be provided. It is let's say service can be what we can say, the live service is there. Let's say it's supposed to be delays, supposed to be very less, and some asynchronous services should be there, that for that purpose is going to be used. Then code 3, host specific route based on the type of service. So these are the 4 redirections options are available to reach that particular destination. So this is the purpose of what, there are multiple alternative paths are available, and that is going to be indicated in this particular redirection. So these all 5 messages are error reporting message, and the second message type is what, the category 2, and the category 2 is what the query message. This is what the assistance message is. ICMP also diagnoses the network problem by using the query message. So this is what the diagnosis purpose is going to be used. Assistance is what provided by the query messages. For this purpose, initially 5 messages have been designed initial level, like echo request reply, timestamp request reply, address mask request reply, router solicitation, advertisement. But out of these 5, only 2 messages nowadays are going to be used, and 2 messages are what? Echo request and reply and timestamp request and reply. Okay. So this is only the syllabus, and every router is following that particular 2 message only. Now here in echo request message can be sent by host or router, and echo reply message is sent by the host or router that receive the echo reply message, echo request message. So to request, the reply is going to be sent. Okay, as a request, the reply is going to be sent. Then echo request and echo reply message can be used by network manager to check the operation of the IP protocol. What are the operations is going to be done at the IP level or IP protocol, that is going to be checked by the manager, network manager, so that he can reply put particular that. Then echo request and echo reply message can test the reachability of the host, whether the host is live or dead. Okay, so for that purpose, what we have utility, and that utility is what the ping. Generally we have a ping command, and with the help of ping command we check the reachability, whether the node is reachable or not, whether the network is reachable or not. Okay, if there is no any network and host is reachable, so we cannot send any packets, so to in order to check that particular and to diagnostic that, let's say if my computer is listening or not, so I have a loopback address 127.0.0.1. Okay, we can check. So for that purpose, these query messages are assigned and designed to diagnosis purpose. This is what the first one. And second is what the query message category. In that, timestamp request and reply. Timestamp request and reply. In this timestamp request and reply, the two machines, let's say host or router, can use the timestamp request and reply message to determine the round trip time needed for the IP datagram to travel between them. Okay, so there is a term is what the round trip time, guys, and round trip time is formula is what? Round trip time is equal to sending plus receiving time. Okay, and how it is going to be calculated? So sending time is what? Receiving time by the receiver and minus original time who has send that message. Then receiving time is what? Receiving time is equal to return time minus transit time, what the time required to transit that particular message. Okay, so there are two codes, 13 and 14, 13 for the request and 14 for reply. There is no any subcode available. So here it can be also be used for the synchronization of clock in two machines. So round trip time is also required to can perform the synchronization of two machines, because let's say if the sending is sending at T0 time and receiver is receiving at T1 time, so it is going to be synchronous activity. Okay, some of the applications need synchronization for the timestamp before they can start, like a live video. Let's say if there is a any live match is going on, let's say IPL is going on, and if, someone is broadcasting from, let's say, some country, and we are listening somewhere in another country, at that time the delay is supposed to be very less. That round trip time is supposed to be what we can say very less. Okay, so the delay is supposed to be very less, so that the uninterrupted service can be available to the users, and there will be no any packet loss. If any packet loss is available, so definitely the service is going to be at the delay end. So this is what the timestamp message of the category 2 of the ICMP protocol. And there is a last advantage and disadvantage of the ICMP protocol. So here, advantage, network speed can be maintained. Why? If we are using, let's say, ICMP packet, if any wrong messages are going to be there, so the wrong message can be discarded via ICMP packet. So definitely the traffic will be very less. Then packet guarantee, that who has sent the source and receiver, in between the source and receiver, it is guaranteed that the packet will be reached to the destination, because we have supporting mechanism. That supporting is what done by the ICMP. And third will be diagnostic utility, like a ping command what we have to check the reachability, whether the node is available, whether the router is available, whether the network is available or not. So these are the advantages. But there are few disadvantages, guys. Sending a lots of ICMP packets increase the network traffic itself. So instead of sending datagram on the network, we are sending more ICMP packets to assist and to report errors. That time network traffic can be increased. One of the reason. Okay. Second will be device performance can be degraded if it received a lot of malicious packet that can cause it to respond with the ICMP red packet. So this can be they can lead to the degradation of the performance of the device because of the lots of malicious packets received. Okay. Third will be the host performance can be degraded if the redirection functions add many routes to its routing table. So if we refer to the routing table and there are multiple paths available in routing tables, definitely in order to check in a routing table, there are multiple entries are available, and in order to process that multiple entry, the performance can be degraded by. Okay, this can be available. This can be possible. End users are affected in malicious if malicious users send many ICMP destination unreachable packets. So this can be like a fraud kind of thing that only ICMP packets are going to be sent. Malicious attacks is going to be there. So in that case also, the this is on this reduce the performance, and this can be this is going to be affect to that particular users. So these are the advantages and disadvantages of this ICMP protocol, guys. But ultimately, ICMP protocol is the what we can say the god to that particular datagram, that it is getting guarantee that the datagrams can be received to the receiver on respective who has sent that particular packets. Okay, so ICMP, and the one slogan is available: if any IP datagram lost or discarded, ICMP packet is going to be what we can say the generate. But if any ICMP packet is going to be discarded, then there will be no any controlling mechanism to the control that ICMP packet. So there no any ICMP error message generated. So this is what all about the ICMP, where we have discussed why the purpose of ICMP, what is ICMP, the header format, then two categories of the messages: error messages and the query messages. There are five and two sub types are available, that all we have discussed with the code and with the example. Thank you. Thank you.